Okay, motion graphs in our syllabus, we divide into two graphs. So we are basically going to learn about displacement, displacement, time graphs, and also we are going to learn about velocity time graphs. Right. So displacement time graphs and velocity time graphs both can be used to do calculations about three things: displacement, velocity, acceleration, or deceleration. Usually, when you take a displacement time graph, there are basically few shapes we learn about how to represent the variation of distance with time. So when we explaining about movement of a particle with distance change or displacement change, we graphically represent it in a graph, which is we called a displacement time graph. So in a displacement time graph, if you want to show that object is at rest or that object is not moving at rest, the stationary or not moving, then usually displacement is S, time is T. You can actually call it ST graphs. So at rest means it is no movement at all. Otherwise, you already moved to another place, which means we started from the displacement zero and we go to another place so that we already made some displacement and you're going to stay there at rest so that the graph may comes to a higher displacement value like this. So displacement time graphs, we can draw exactly zero lines for a value with a certain displacement depending on the displacement we made. Second thing is about constant speed or constant velocity. Right? A constant velocity means displacement is increasing at a constant rate, which means displacement we if we are going to move, we increases the displacement, we change the displacement with the time. So that kind of a thing we normally draw as this. So this is a straight line passing through the origin like this. So this shows that displacement increases kind of proportional to the time. In another word, increases with time. We can also call this a linear increase or linear change also. The linear means it changes constantly. And also, we can represent this a constant acceleration, and also constant decelerations. Right. In a constant acceleration, these are again ST graphs. Constant accelerations, what we do is we can increases the displacement more rapidly. If you accelerate, acceleration means we increases the displacement at a more greater rate or more rapidly we increase. So a constant acceleration represents about increasing curve lines. And constant deceleration means it's a decreasing curve line like this, decreasing curve line. So uh, both of them are curve graphs because why? The displacement increase also increases. So these are the four basic shapes that we get to draw in a displacement time graphs. But there is other two more important things about displacement time graphs, like displacement time graph, gradient of the graph, gradient of the graph is equals to the velocity. Gradient is velocity. Like, for example, in a ST graph or displacement time graph, if you have a line like this, kind of a straight line, and I'll draw another color, this kind of a straight line. So this has a greater slope, and this has a smaller slope, right? So a smaller slope means smaller velocity, smaller velocity, and a greater slope means a greater velocity, greater velocity. So the slope of the graph or the gradient of the graph represents how the velocity changes. If you have a greater gradient, which means a greater velocity, with a smaller gradient, it's a smaller velocity, right? That's the important fact about the displacement time graphs, right? The other type of graph is we called velocity time graphs. So velocity time graphs, sometimes we call VT graphs. In a VT graph, there are again some basic shapes that we need to usually know. Right? A graph at object at rest, which means object is not moving. So if the object is not moving clearly, there is no velocity. At any cost, there is no velocity. Always the velocity is zero. Always it's zero. And this is at rest. And there can be constant velocities. Constant velocity. A constant velocity means the velocity always maintains constant like this. So which means with time, the value of velocity is not changing, remains same all the time, which is a constant velocity. Now, we should not get confused with the graphs we learned here and here. So the displacement time graph has a separate way of explaining that shape, and a velocity time graph, you have a separate shape for that, right? Then the next thing is constant accelerations. Constant acceleration. Constant acceleration means this is a constant increase of velocity. So this is a constant increase of velocity means acceleration should show that velocity has an increase. Acceleration means an increase of velocity. And if it is a constant acceleration, which means the velocity should increases constantly, constant increase of velocity. And constant deceleration. Constant deceleration. A constant deceleration means the velocity decreases gradually with time, like this. So the velocity should be decreasing gradually with time. That is what you call a constant deceleration. So now at rest, constant velocity, constant deceleration, constant acceleration. Now the same graphs, you can compare how the displacement time graph shows that and the velocity time graph shows that they have different shapes. So we have to basically remember the difference of that. And also, we have these two important points from this graph. Like the two important things about velocity time graphs are area under the graph is equals to the displacement. Displacement and gradient of the graph. In a gradient, we also call the slope. So the slope of the graph represents the acceleration or deceleration. You can find the both from the graph gradient. And acceleration. Now suppose we have a graph like this. VT graph, velocity time graph, and it shows these values like 10, 20, 25, 40 meters per second and seconds. So now in a question, if they ask you to find what is the displacement uh, that the whole journey counts, which means you have to calculate the area under the trapezium given here. So the overall displacement is area of the trapezium, which is half into two parallel sides, which means this side, which is 10, plus this overall side, which is 25, into height, which is 40. So that we get 20 times 35, which is 700 meters. See, you can find the area if you know the area equation, whether it can be a triangle. Sometimes they'll ask you to find area only within the first 10 seconds. So in that case, you need only this triangular area. So you have to understand according to the question which area they want you to calculate. So based on that, you can calculate it. At the same time, if they want you to find the acceleration of the graph, here the acceleration part. This is a part where it's accelerate. This is a part where it decelerates. So the acceleration is the slope of the graph. Slope or the gradient of the graph. So we can find it from this value, which is 40, this value, which is 0. So 40 minus 0 divided by time, which is 10, which is you get 40 divided by 10, which is equals to 4 meters per square second. So we can find in that way the acceleration. So that's how you do calculation based on displacement time graph and velocity time graph. So remember, there are two important points about these graphs. We have all that important points in the summary, that gradient is the velocity, and in a velocity time graph, gradient is acceleration or deceleration, and area under the graph is the displacement traveled, right? So I did a small example of how to do that. Yesterday we learned about two equations. One equation was V equals U plus AT,
Karen? Arlam. Arlaun ke sababan.
right? And the other thing is, other equation is V squared equal U squared plus 2AS. These are the two motion equations I have mentioned yesterday that you need to know for the calculation of these components. So V is the final velocity, and U is the initial velocity, and A is the acceleration or either deceleration, and T is the time, S is the displacement, right? So these factors are the main important points that you need to know to do the calculation or mostly the theory parts of this graph section. And this is all we have for the graph section other than your calculations. Uh, Hopefully you understand this part. And now, if you have any doubts, you can ask.